skeletons and ninjas, all sorts of fun stuff.
So it's basically World War Z.
Or a robot. That's not a skeleton, it's a robot. You're
I
right.
thought they were cactuses.
Huh? Well, that's a zombie, that's a pirate, that's a ninja, and that's a robot. It's my zombie tie. All right, here we go. Anyway, so we're talking about transformations today of polynomials. So x to the fourth, x to the fifth, x to the sixth, x to the 475,000, that sort of thing. All right, so we're still got the whole y equals a parentheses bx minus h plus k. Yeah, somebody want to hit the right light switch for me?
New packet, right?
Yep, new packet back there. All right. So, and honestly, we were going to have you write all this in, but what's the point? It's right there. It's good to go, and all that sort of stuff. So, horizontal and vertical translations, aka shifts. First things first, I want you to write shift, because the book uses it interchangeably. Okay, those are shifts. All right, so for all of these, you have to write three things down. You need to write what it is, which direction it's going, and how far. So we want to know what is it. Okay, we want to know what direction it's going. D-I-R-E-C-T-I-O-N. And how far. That is the three things you have to answer about transformation.
Why is it comma after what?
Because we have to answer what it is. I'll have to answer which direction it's going. It's three different things. It's a list. Okay. So what is it, which direction, and how far? There are three types. We have if we are adding or subtracting. We call those what? A shift. Very good. You zoom in. S-H-I-F-T. If we are multiplying or dividing, what do we call those?
Translation.
That would be shifts.
Shrink.
Those are a shrink or a stretch. Those are stretches and shrinks. So stretch or shrink, which is a highly technical term, S-H-R-I-N-K. The rest of the world uses the word compression.
Shrink.
I don't know why we're using shrink, but it is what it is. All right, then we have if you are multiplying, M-U-L-T-I-P-L-Y, by a negative. That is a reflection, exactly. And my pen is wearing out. Is a reflection. Okay, so those are the three different types. We got shifts, we got stretches and shrinks, and we have reflections. Cool? So here's how we're gonna use this thing. I got 5 sections. I got section 1, section 2, section 3, section 4, section 5. That's how I'm going to refer to them today. Okay? That's not how I'm going to refer to them for the rest of the unit, but that's just how we're going to talk about them today. So, for problem 1, down here, you got a plus 5. Is it inside the parentheses or outside the parentheses? Inside. So let's go up here. Which section does that fall under? Section 1, 2, 3, 4, 5. 1. It's the one where you're adding or subtracting on the inside. And since it's minus 5, are we going to the right or are we going to the left?
To the right.
To the right. Oh, it's a plus. It's a plus. I'm sorry. I saw it is a plus 5, so we're going to the right. My bad. So, it is a shift. That's what it is. I don't need a comma. It's a shift to the left. Almost right again. Shift left 5. That's what it is. That's where it's going, and that's how far it is. It's a shift left 5.
Right. Left or right?
It's right.
It's right. It's positive.
Let's look at the chart real quick. Worst case scenario, we are adding, it goes to the left. Remember, everybody at home you know is crazy, but outside the house they know how to act. You remember that? Yeah. Inside the parentheses, everybody is nuts and you know it.
Yeah.
N-U-T-Z, nuts. And so it's backwards. No. Outside the house they know how to act, except for crazy Uncle Benny. Ain't nothing helping him. All right, so let's go back down here. That's the positive 5. What about the positive 2? Which section is that? Box 1, 2, 3, 4, 5. 2. So it is also a shift.
Shift up what? Shift up 2.
Shift up to 2, yeah.
Good. Shift up 2. Cool. So again, if you're over here, we say, oh, well, it's plus on the outside. We're adding, and so it's that one right there. It's a shift up 2. Cool.
Cool.
Any questions on that?
No, man.
Really is that difficult? All right, let's talk about graphing this quick. This is so hard. You ready?
No.
Get out a calculator. Remote desktop. What am I gonna? I need my calculator. No, I don't want that one. I want. Did I close the calculator? I closed the calculator. For shame, for shame, for shame. Well, come get another one. Give it to me. TI-80 Smart View. All right, so plug the equation into y equals. While mine's loading, go ahead and plug it into y equals, okay? It should be loading. I think it's loading.
Plus 2.
It wants to load. Where did it go? There it is. Now I just got to move it over to the right. Yay! All right, so here we go. I'm going to go to y equals. There's my cursor. Y equals. Clear that out. So we got, what is it? X plus 5. Oops. Plus 5, close parentheses. To the 5th or to the 3rd?
To the 3rd.
To the 3rd. Plus 2. Scoot it out. Scoot it over. Plus 2. Okay? And so you can graph it if you want. That's kind of what it looks like. And remember, on your graph at home, I don't want, or on your page or whatever, on your test, I don't want you just going to go, yeah, something like that. You follow me? Okay, that's a Jason Pollock painting, okay? If you don't know who that is, look him up. You'll find him instantly. Or Jackson Pollock. Jackson Pollock? I think it's Jackson. All right, anyways, so here's the deal. So go to the table. Second. It's just easier if I use this. Second table. What I want you to do is I want you to grab all the points that fit plus one more. So like right here, that fits, right? The -6 fits. So grab the -25. Grab the -25 all the way down to the +29. Grab everything that'll fit on your graph plus one more. The reason for that is we have seen graphs so far this year that do some really weird stuff, right? All right, they do sometimes. So like, I don't want you to go along and think, oh, well, this goes up to infinity, when in reality it just kind of stops and goes wonk, straight down. You follow me? So you think it's going up, make sure it's actually going up is why I want you to get that extra point. All right? So here we go. That's what? -25, -6, 1, 2, 3, 10, 29. All right, here we go. So it was -8, -29. So 1, 2, 3, 4, 5, 6, 7, 8 off the chart. Come on. Come on, Betsy. All right, -7 was what? -6?
Yeah, -7, -6.
-5, 1, or -6, 1. What is it doing? -5, 1. Or -6, 1, -5, 2, -4, 3, -3, 10 is what it gave us. And the last one was like 17 or something like that, right?
Yeah, 29.
Or 29, yeah, something way off the chart. All right, so those are our points. And so we're going to take this and go, we're off the chart, we'll kind of go like that, and we'll keep on going. And I missed my line, but my point, but so what? Okay? Yeah, you're right. If the points weren't there, that looks like a Jackson Pollock. You're absolutely right. It kind of looks like I just went, yeah. You're right. But the points legitimize it because I cannot write, and we all know this. All right? That's just what it is. So like I said, the graphing is the hardest part. Just take in your calculator, get some points, be done with it. You should never fail a graphing test, ever.
You're giving a scary movie with that voice.
I could do a scary movie. All right, anyways. Okay, letter B. Let's keep on going. Letter B. Let's keep rolling. Letter B, letter B. Letter B, letter B. Okay, anyways. Enough of the Beatles. -2 on the inside. Go back up to your chart. Which one is that? Section 1, 2, 3, 4, 5.
1.
1! Okay, so it's a shift.
Right 2.
Good, it's a shift to the right 2 units. All right. What about the positive 1?
That's a shift up 1.
Good. It is also a shift. Why is my thing lagging so bad?
You don't have enough to the WAN.
Oh, I know why I'm. It's because I'm recording as well. I forget that. Shift up 1. All right. Yes, sir. All right. So that's those. How do we graph it? There we go. So pull out a calculator. Plug that sucker in. That might be true. Y equals.
Hey, that's a song by Metallica.
It is a song by Metallica. So X, what? Is it minus? I can't see it anymore. What is it?
-2.
Minus 2.
Four.
2 to the 4th. Plus 1.
Sorry?
Okay. So if you want to look at the graph, there it is. It's a parabola, but the bottom's been kind of squished up a little bit. All right. So if I go to the table, wow.
Nothing fits.
No, there's a few things that fit.
There's 3.
Yeah, there's 3 points that fit.
And then you can put one off.
So I can put one off the graph at the 0, and I can put one off the graph at the 4. So we're gonna go 17, 2, 1, 17. Go back. So I got 17, 2, 1, 2, 17. You get something that looks kind of like this. Kind of. Yeah, let's try that again. That was horrible. The ladies' man does not like that. Felt like my hand was about to break. But there we go. And so there's your graph. Okay? I know it's been nice and quick, but have any questions about this so far? All right, turn the page. Told you today was easy. We're gonna at this point, I'm gonna trust that you can graph all these on your own. Okay? Who here has a Android device of some type?
See, I hate it how it's only for Android.
Great. Okay. Who here has? You can download this calculator. They have like 5 free ones around for that TI-84. Who here has an Apple? All right. Oh, it's off the board. I erased it. Download Desmos. D-E-S-M-O-S. Write it on your page. Don't download it right now. You can download it later. Desmos. Okay. It is basically just an online graphing application. It doesn't do all the calculating and all that sort of stuff, but you can plug in any graph and it will graph it for you. And you can click on it and find all the points you want. Cool? It's nice and pretty. It's actually probably the most user-friendly one I've found. All right? So here we go. Transformation. At this point, I'm going to stop graphing because we don't have time for that. We just straight don't. So here we go. I got a negative 1/4 on the front. I want you to flip back to the other page. I'll leave this up for shit. So, which section does this fall under? Okay, the third is one of them. It actually falls under 2. It falls under the third one. What other does it fall under? The 5th one. Okay, so here we go. Let's watch. Let's go wide. Here we go. It falls under the third one because of the negative. All right? So is the negative inside or outside? It's outside, so it's going to reflect across the x-axis. Okay? The negative is on the outside, so it's a reflection across the x-axis. The 1/4, is it on the inside or is it on the outside?
Outside.
It's on the outside, so it's a fraction. It's a shrink. Cool. It is a vertical. I don't know what that was about. It is a vertical shrink by 1/4. Cool. All right. Boop.
By whatever, bro.
Boop.
Don't.
It's the K-Max song. So, okay, the negative is a, no, not with the eraser. Reflection across the x-axis. And I know it says over and not across. You can write over this just fine. It's just a force of habit for me. And a vertical shrink by, and you can say 1/4 or you can say by 4. Because if I'm shrinking by 4, do you really think I'm multiplying by 4? No, it just makes no sense. So you could say by 1/4. To say shrink by 4 or shrink by 1/4 semantically means the same thing. Okay? All right, let's look at letter B real fast. Letter B. We got 2 things going on. All right, don't yell it out. Take 20 seconds and look at it. The 2 on the inside. Which category does that fall under? 1, 2, 3, 4, or 5? Is the 4th one. All right, it is multiplying on the inside. Here, Daniel, flip back over. Look at it, look at it. All right, is this, what would you say this is doing to x? Would you say this is adding or multiplying? It's multiplying on the inside. So it is a horizontal. Is it stretching or shrinking?
Shrinking.
It is shrinking. Good. I don't need to say shrinking. I just say shrink by 2. All right, what about letter number 3, the negative 3? Which category does that fall under? 1, 2, 3, 4, or 5? Well, Terry, is it multiplying by a negative?
Oh, no.
It's just subtracting, right? Yeah, so that would be the second one. Very good. So that's a shift. We know that. Which way? Down. How far? 3. All right, how are we doing this? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3, and 2, I'm lost. 1, save me. All right. It's at this, I don't understand this at all. But at the beginning of the year, everybody sees transformations, and they're like, oh my goodness, what is this wizardry you have put before me? And very few people understand it. But then we do it again in October, late September, early October, and you're like, okay, I'm getting a little bit of it. Then we do it again in December, and you're like, well, maybe. And now is when everyone finally goes, okay, this kind of makes sense what we're doing now. I don't understand why, but this is when it starts to sink in, which is what it is. And if it's not, come talk to me. We'll bang it in with a hammer if we have to. Okay? I'm kidding. We won't do that. Just, square peg, round hole, that sort of thing. All right. Do letter D real fast. Switch over to letter D. Take, 30 seconds and knock out letter D real fast. In theory. We're going to stop this conversation right now because I see this going south really fast. That's true. I am still recording, you're right. Stretch.
By 2, right? This is like.
Yeah, well, you can say it by 2 if you want. Huh? You can say either way. Yes, ma'am. Yes, you may.
Wow, you're smart.
All right. I'll take a second. I'll let people finish up, see what's going on. All right. Now, some people, you may have put a 1/2 right there. That's fine.
I forgot to put all that.
Okay. It does not matter if you put a 1/2 there or not, because it is by factor here. Here's why I don't like necessarily putting a 1/2. Does it make sense to stretch by a 1/2? Does that make sense? No. That's why I say whether you put the 1/2 or not, it's okay. I will accept both. Yes, ma'am. Why is it not a shrink? Okay, first things first, everything inside the parentheses is backwards. So instead of dividing by 2, the effect it has on the graph is as if it was multiplying by 2. That's the effect it has. That's why it's a stretch. All right, that's what's going on. All right, good question. Any other questions? All right, let's change it up a little bit. All right, next thing. How do we apply a transformation to an equation, okay? How do we apply a transformation to an equation? What's going to happen here is we're going to say, hey, here's an f of x. Put it in the box. Here's an f of x. I want you to make a new function, and I want you to do this to it. All right? So we're going to talk about first how to unpack this little guy. It is way difficult. No, not really. So here we go. I'm going to give us some space up top. Come on. Zoom. Whatever. Let's say we got f of x like this. Anything on the inside, you substitute for x. So if you have a 2x in there, everywhere you see an x, you put a 2x in its space. All right? Anything on the outside, let's change my colors, let's do green. Anything on the outside, anything added on the outside or anything multiplied on the outside literally happens on the outside of the equation.
What do you mean by sub for x?
Substitute, I mean, instead of an x there, we're going to write whatever is in this space. Okay? Oh, hush, dude. So here we go. Anything inside, we're going to substitute out for x. It's kind of like it works it right from the inside. Anything outside, we're going to put on the outside. All right, so here we go. Letter A. For this one, is this negative they're adding to it, is this on the inside or the outside? Inside. So I'm going to put a negative x and replace all of these x's with that. So here we go. That would be g of x, that's our new function, equals, instead of x, put negative x, and cube it. Plus, oh look, there's another x. So put a negative x in its place, and square it. Plus 1. Cool? Anywhere you see an x, you substitute it with everything that is inside the parentheses. If it was a negative 2x plus 7 in there, we would have put a negative 2x plus 7 right there and cubed the whole thing. Which, yes, sounds like a pain in the butt, and it is. That's why we're not doing it. All right. Now just clean it up. If I have a negative and I cube it, if I cube a negative, is it still negative or is it positive?
Negative.
It's still negative. Okay. So it's a negative x to the third. If I take a negative and I square it, it becomes positive. So that's negative x cubed plus x squared plus 1. And that is the resulting function. If I apply this transformation, that is the new equation. Cool? Effect, all you did was add a negative out front. You're right. But if I wanted to, this is a reflection across the y-axis. This would be the equation if I reflected it across the y-axis. That would be the new equation. That's what it is. Cool? Wow. Clear eyes. Wow. All right. Let's switch to the right. Let's keep going. All right. This one tells you to do what? We want to multiply by 3, but do we want to put it in place of x, or do we want to put it on the outside? Outside. So basically, these are the hard ones. You ready? G of x equals 3 on the outside of the whole thing. No, no, I'm being very sarcastic. There's a reason we only gave this lecture one day. All right, we're not taking a break tomorrow to practice. Yeah. All right, it is that easy. Tell Jonathan to come back. All right, so clean it up. I know. So where are we going from there? Exactly. Just distribute it. Basically, we're cleaning it up is all we're doing. All right? So g of x equals 3x to the fourth plus 3x cubed plus 3. Just distribute it, and you're done. And when it comes to graphing, just plug it in, and graph it. Cool? Don't overthink these. All right, how are we doing with this? Give me 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. 1, save me. All right, let's go down a little bit. Let's glance at letter C real fast. Okay, so this negative. Would I put it in place of x, or would I just put it on the outside? Put it on the outside. So honestly, we can just go g of x equals negative x to the 4th minus x cubed minus 1. There's no sense in rewriting that. You can just flip all the signs. Okay? Cool. I just multiplied all by negative. Letter D. Letter D, I want to change a little bit. So we're going to scratch this one out. We're going to scratch it out. And in its place, I'm going to write g of x. I still don't need an eraser. I need a pen. There we go. G of x equals 0.3 f of 2x. Cool?
No.
I know. This one's a pain. We got something on the inside and we got something on the outside. What are we multiplying on the outside? Oh, let's put one more thing on there. Let's put a plus 4. Why not? Why not? I mean, let's just do it. It is easy. The reason is I don't want you to get your homework and see this and go, we didn't go over this in class. I guarantee you there are people that'll do it. So here we go. What are we going to put out front?
0.3.
0.3. So my new function g of x has 0.3. What are we putting in place of x? 2x. Take the x with it. So 2x cubed plus 2x squared plus 1. Do we need to put anything else out there? Plus 4. Sweet. Good shot, Red 2. All right. So start cleaning it up. It is from Star Wars. All right. So what is 2 to the 3rd power? That's 2 plus 2 plus 2. 2 times 2 times 2 is 8. So 8x cubed. What is 2 squared? 4. All right. What are you going to do next? Distribute the 0.3. Which, don't overthink this. What's 3 times 8? 24. Move the decimal back and you get 2.4x to the 3rd. What is 3 times 4? Move the decimal back, you get 1.2x squared. What is 0.3 times 1? 0.3. Let's go ahead and add the 4. So that's 4.3. Cool? And that is the resulting function. The resultant function. Cool? All right. I want to do at least one like this so you don't get... There's going to be always a couple people that go, what? All right. Next page. Last bit, and we'll quit. Again, it's the same thing. It just comes at it from a different angle. Now you have to read. I know.
Mr. Hunter, in the homework we have to graph it.
If it says to graph, graph. If it doesn't, then don't. Straight up. If the instructions say graph, graph it. If they don't. All right, so here we go. Let the graph of g, so we're going to make a new function, g of x, be a vertical stretch by a factor of 2, followed by a translation, aka a shift, 3 units up. So, if I vertically stretch by a factor of 2, you've got to switch back to the front. Are we going to put a 2 on the inside to vertically stretch, or are we going to put a 2 on the outside? Good. So here's what I'm going to do. I'm going to create myself a little rubric to know, hey, I'm putting that 2 on the outside. Cool? 3 units up. Okay, how do you express 3 units up? Plus 3. Would I put it inside or I put it outside? Outside. So that is what we're doing to the equation. Do you have to write this section? No. It is simply a way of organizing what's written down into something in more like math terms. Cool. So here we go. g of x equals 2 times x to the fourth minus 2x squared plus 3. So what are we going to do? I told you today was hard. It is. It's just, it's like killer. Are we still doing all right? Anybody have an aneurysm yet? All right, good. Last question, we'll stop. I promise. Last question, we'll stop. Slide down to letter C. The function v of x equals 1/3 x cubed minus 2. So the function of this represents the volume of the square pyramid shown. The function w of x represents the volume when x is measured in yards. So basically they're going from feet to yards. Write a rule for w, so that's the first thing I want you to do, and then interpret w of 10. Okay? So, if we're going to write the rule for w, are we putting 3x on the inside, or are we multiplying the whole thing by 3? 3x on the inside. It is inside the parentheses, so we're going to put it on the inside. So w of x equals 1/3 3x cubed minus 3x squared. And then we can clean it up a little bit. Anybody remember what 3 to the third power is? 27. But then we got that 1/3 out front. So what's 27 divided by 3? 9. So nu of x trace a. You got to put an A on the end of everything it makes in Spanish. Trace a. You a, want to a, go to a. I'm just being bad. All right, what is 3 squared? 9. It's kind of like pig Latin. So that's your new function. Good. What else does it tell you to do? Interpret at w of 10. So if I've got w of 10, what is it asking you to do? Plug in the 10 to x. So that's 9 times 10 to the third. What's 10 to the third power? 1,000. What's 1,000 times 9? 9,000. Minus 9 times 10 squared. What's 10 squared? 100. 100 times 9 is? 900. So what's 9,000 minus 900? There you go. Booyah. So 8,000 square or cubic yards will be your final answer. And I'll clean that up real fast. Any questions, comments, concerns, complaints, limericks? All right, let's be done with this.